All right, hello, C++. We're on page 251 with the topic of function templates. Now, function templates are wise for us to use if your program logic and operations that you're now designing are identical for each data type. Then use the compact and convenient implementation of function templates. You simply write a single function template definition. The argument types provided in the calls to this function are then by the C++ compiler automatically generated to provide separate function template specialization. A special template specialization is found on page 253 at the bottom, where the special template specialization created for temp int replaces each occurrence of uppercase T with int as follows. We'll see that the compiler does this automatically for each data type that is sent to the called function. Function template specializations will handle each type of the call automatically. Thus, defining a single function template actually defines a whole family of overloaded functions for you. But we're going to look at a maximum example where we have a maximum template, and it is defined in a header file on page 252, and the test program is on page 253. So at the top of page 252, we are defining a header file, maximum.h, and we're going to define the function template. Function template definitions begin with the keyword template, followed by a template parameter list enclosed in the greater than, less than symbols. So here's the keyword template and our greater and less than symbols. The keyword name, type name. The type parameters are placeholders for fundamental types and any user-defined types. These placeholders in our example are uppercase T. So we have one placeholder and we're calling it uppercase T. The placeholders are used to specify the types of function parameters to specify the function. So we have a return type and to declare variables within the body of the function definition. So when we declare the function, we have a return type of T. Maximum is expecting a T value 1 and a T value 2 and a T value 3. The function template is defined like any other function, but uses the type parameters as the placeholders for the actual data type. So in our program, line 3, we are writing the definition for our maximum function template. We're defining it within the code of maximum.header file. The function template in line 3 defines a single type parameter, T, as a placeholder for data type to be tested by the function maximum. The name of the type parameter must be unique in the template parameter list for a particular template definition. When the compiler detects a maximum call or invocation in the program source code, the type of the arguments in the maximum call is substituted for T throughout the template definition. And your C++ compiler creates a complete function for determining the maximum of 3 values of that specific type. Now, all 3 must have the same type. That is, we're trying to write or create a template to determine the maximum of 3 same data type values. But because it's the same logic, we're now sending a placeholder for our data types. And remember, we have integer data types, double, float, character, our user data types, class objects, and so on. So all 3 must have the same data type, but we're recalling the template and allowing the compiler to make the complete definition with the data types that are sent to the calling environment. Since we use only one type parameter in this example, we're using the same data type for all. Then the newly created function is compiled. Templates are a means of code generation because the compiler does indeed generate the function template specialization for whichever data type. Our example on page 253, the code generation for function template specialization when our T template placeholder is of type int. The compiler fills in and completes the code for every occurrence of T with int. So we can use our program figure 06_23.cpp as our template testing program. And it processes the largest of 3 int values and returns that value, processes the largest of 3 double values and returns that value. We also have an example of our function template accepting 3 character values and returning the largest of those 3. Because each call uses arguments of different types, the compiler creates a separate function definition for each. One expecting 3 integer values, one function definition expecting 3 double values, and one function template specialization expecting 3 character values. So we count on the compiler to allow us to automate with some stipulations on the same data type, but the implementation, the logic, and the processing is the same. So we're saving ourselves time by designing a function template. So let's look at our example. I apologize, I don't have this up already for you, so we'll start from scratch. All right, let's look at our maximum.h, our header file, which is the function template definition. Our keyword template, and then within less than, greater than symbols, we have type name, and we're using uppercase T in this case. That can be a chosen variable by you, and that should be of uppercase and a single character by convention. Then we have our begin end block of our function maximum. Maximum is going to return a T value, which is our temporary data type, depending on what type is sent to the maximum function from the calling environment. So we have maximum as the name of our function, open paren. T is our temporary placeholder, and we have a value 1. T is a temporary placeholder, we have our value 2, and T is a temporary placeholder, we have our value 3. So maximum is expecting that 3 values will be sent to it when it's called from the calling environment, all of the same data type. And then we assign maximum value and initialize it to value 1 that was sent to the function. Determine if value 2 is greater than. Well, we're kind of familiar with this. We're trying to determine the largest of 3 input values. If value 2 is greater than maximum value, then value 2 would be the maximum value. We're going to reassign maximum value. If it's not, we continue to test value 3. If value 3 is greater than maximum value, then we're going to reassign maximum value, the value that was sent as value 3. And we're going to return maximum value as the current data type within the temporary placeholder, and that returns to the calling environment. Let's look at our driver program. This is a template. We're using a function template maximum, and this is the program that will test it, our .cpp driver program. Include IOStream, include the maximum header. Don't forget to do that, and this is a user-defined function template. This is your own designed header class file, so you want to make sure you use the double quotes, and we're using our namespace directive. Int, you see that begin end block within the main function. We're going to prompt the user and input 3 integer values, accept those from the keyboard, and then call our maximum header class file, sending 3 integer values. Our definition of our maximum template function will accept 3 integer values. The compiler will generate the code for the function template specialization for type int, replacing our temporary placeholder t with integer, and return the maximum of 3 integers. We continue within the driver program. We're going to demonstrate what happens if I send 3 double values. Well, input 3 double values from the keyboard, accept those, and assign to double 1, double 2, and double 3. And then we're going to call the maximum template function again, sending 3 doubles. So the compiler will now generate, I'm on page 253 at the bottom, the compiler will now generate code for the function definition, replacing every occurrence of t, our template placeholder, with double instead of int, our example in the book. So every occurrence in our function, the code will be generated for the function definition, replacing the t temporary placeholder with double this time. So our function definition is intact, and we will call the maximum template function. It will accept 3 doubles. The temporary placeholder will generate code for the function definition with a double return and accepting 3 doubles within the function, and return for us the maximum of 3 input doubles. And then our next example is to demonstrate the maximum with our character values. So if I type in 3 separate characters and assign them char 1, char 2, and char 3, and then call my maximum header function template, the temporary placeholder will accept character type, and again generate the code for the function template specialization, replacing every occurrence of t, the temporary placeholder, with character, and will return the largest of 3 characters. Let's go ahead and run this. It's prompting me to input 3 integer values. Remember, spacebar. My largest is the first value. and the maximum integer value is 78, which is correct. And now it says input 3 doubles. Make sure they're double values. Space, space, and enter. And the maximum double value is 66.6, which was actually the second value that I entered. And now input 3 characters. Well, let's enter C, B, A, B, C, where the last value is the largest character. And sure enough, the maximum character value is C. The process of calculating a maximum of 3 input data types is the generic function template. And depending upon the data that is sent to the function template, your compiler regenerates the code for the function definition, replacing every occurrence of the template placeholder, in our case uppercase T, with the data type that was sent to the maximum.h function template. So pretty cool. Saves us a lot of work. We're again counting on the compiler to do the underlying code generations for us. All right, thank you very much.